Okay, so hello everyone. As you know already that learning in the class may not be suffice for everyone to grasp all the critical point of mathematics in our textbook. So I decided to create this video just to give you further explanation about the concept of the similar figure as well as the similar triangle that you already learned at school. And I also provide you one exercise as the example so that you can understand clearly about the content. So here we go. Okay, so firstly, I would come up with the question, how do we know that the two figures are similar? Can you answer this question? I think you have learned already at school, so I hope that you can answer this question. However, I would like to give you some further basic concept of the similar figures. The first point is that similar figures have the same shape but not necessarily the same size. For example, you may use your phone every day, and in your phone there are some pictures so that you may use that tool also. You may see your pictures, and then you want to see your pictures clearly or not. You will zoom it in or zoom out. So this concept means that your picture is it's still the same shape, uh, it's the same shape, but when you zoom it or out, so that the size may be different from each other. Sometimes the size of that pictures may be bigger or bigger, so smaller and smaller. It's according to whether you zoom in or zoom out. So this concept means that your picture is still the same shape, but might be different size according to whether you zoom in or out. So this concept means that the pictures in your phone is still it's called similar figure or similar pictures. The second point is that the corresponding angle of the similar figure are congruent or equals. And the third is that the corresponding side of the figure are in proportional. What does it mean in proportional? Which means that the ratio of the corresponding side are equal each other's or equal to a constant number. So when the ratio of the corresponding side are equal each other or equal to a constant number, so that the ratio of the corresponding side is called scale factors. Normally we label as k, which means that k is the scale factors. So here is the concept of similar triangle. As we already know that about the concept of similar figure. So similar triangle, it's the same as similar figure, which means that shape is the same but not necessarily the same side. Corresponding angle are equal. Corresponding side are in the same ratio, where the ratio of the corresponding side is equal to a constant number labeled as k. For example, in this figure, you may see that the corresponding angle of x is here, x also, and the corresponding of y here is y here, is the same. Z and z here is the same. So it means that uh, uh, all the corresponding angle are equal. In other words, the corresponding side of A is P, the corresponding side of C is R, and the corresponding side of B is Q. So the ratio of the corresponding sides, such as A over P equal B over Q equal C over R equal a constant number, which is normally labeled as K. However, in order to test whether the two triangle is similar or not, we don't need to prove all the six corresponding element as I stated earlier, like the three corresponding angle are equal and the three corresponding side are in proportional. However, we just prove some of the element here, such as the first point is AA, which means that if two corresponding side, if two corresponding angles are equal, which means that we can conclude that those triangles are similar. The second point is that SSS, which means that in order to prove that the two triangles are similar, we can find that whether the three corresponding sides are in the same ratio or not. If they all are in the same ratio, which means that they are in proportional, so that we can conclude that those triangles are similar as well. And the last one is that SAS, which means that the ratio of the two pair of corresponding sides are equal and their include angle are equal. So when we found that the ratio of the two pair of corresponding sides are equal and their include angle are equal as well, so that we can conclude that those triangles are similar. So remember that in order to prove that the two triangles are similar, we just look for the three conditions as here, AA, SS, or SAS. So this is the example for use. Remember that in order to solve the exercise, you need to read those exercise clearly and make sure that you understand the question clearly before you start doing that exercise. For example, a building sit on a horizontal ground and Young used two poles 6 meters apart to find the height of the building. Pole A is 1 meter high and pole B is 3 meters high as shown in the figure. So the first question is that prove that triangle OAM is similar to triangle OBN. B, find the length of OM. And C, find the height of the building to the nearest 10th place. Sorry, here's 10th place with E at the end. So when you read this question, do you understand this question? If you do not understand it, you may read it again and look for the figure given so that make sure that you already understand the question. So in here, a building sit on a horizontal ground and Young used two poles 6 meters apart to have. So the two pole here which refer to AM and BN is the two pole, which is the two pole is 6 meters apart. You may see that the distance from M to N is 6 meters apart. Pole A is 1 meter high and pole B is 3 meters high. You can see that the length of AM is 1 meter high and BN is 3 meters high, as shown in the figure. So in the figures, they also provide you the distance from N to P is 80 meters as well. So prove that triangle OMN and triangle OBN, OAM, and OBN is similar. And question B, find the distance or the length from O to M. And C, find the height of the building to the nearest 10th place. So where is the height of the building? So the building you can see in what's the pink color here. It's the building, and the height of the building is represented by TP, as you can see here. So how do we prove that the triangle OAM is similar to triangle OBN? Okay, so here we go. Look at the solution together. So this is the solution, which means that the question is that prove that. Okay, so here the answer should start with prove. I'm sorry to make this mistake as well. It should be proof that triangle here and triangle OAM and triangle OBN is similar each other. So in order to prove, you can look for the three conditions as I mentioned in the previous slide. We have three conditions as AA, SSS, and SAS. So can you find whether which condition should we can prove in which condition? So in here